All right, it's time to play your favorite game. Who's that particular solution? Woo! This time systems version. And for this, guess the form of a particular solution to x prime equals ax plus f, where a is 1, 1, 4, 1. And before I even tell you what the right-hand side is, your first instinct should be to find the eigenvalues, because that's what helps us find resonance. And this you can check the notes. So it turns out the eigenvalues are lambda equals -1 and lambda equals 3. And now we can actually start. So what is the first game? Let's do f of t equals 2e to the 2t minus 3e to the 4t, and then e to the 2t plus e to the 4t, which is useful to split it up as e to the 2t times 2, 1 plus e to the 4t times minus 3, 1. So here for resonance, we'll look at the right-hand side. So we have e to the 2t and e to the 4t. That corresponds to lambda equals 2 or lambda equals 4, which does not coincide. With lambda equals -1 and lambda equals 3. So no resonance. Which means we can just guess our usual thing. So in this case, xp of t is e to the 2t times a constant vector ab plus e to the 4t times another constant vector minus 3. All right, next round, let's do f of t is cosine 2t it's cosine 3t. I mean, not that it matters. So cosine 3t and 2 cosine 3t. So here, the right-hand side, if you want, it's cosine 3t times 1, 2. So here, the right-hand side, because of the cosine, corresponds to lambda is plus minus 3i, right? Complex eigenvalues give you cosines and sines, which again does not coincide. And so again, no resonance. Which means you guess your usual thing. And remember the rule, cosine always goes with sine. And so this gives you cosine 3t times a vector, AB, plus sine of 3t times another vector, CD. All right, let's now do polynomials. So f of t, let's do 2t minus 2t plus 3 and 3t squared, t squared plus 4t minus 6. Technically, that corresponds to eigenvalue 0, because we have an e to the 0t, but here there is no resonance. The question is, what do you do here? Because notice the top has degree 1, whereas the bottom has degree 2. And what you do, you want to guess the most general thing, so guess degree 2. So always take the bigger one of 1 and 2, and what that gives you is xp of t So we want AT squared, but here is a vector. So T squared times AB plus BT, so T times CT plus EF. Or in other words, AT squared plus CT plus E, and then BT squared plus DT plus F. So again, the same thing as before, AT squared plus BT plus C, but this time as vectors. Last but not least for this round, let's just combine everything. So F of T, let's do it 2T plus 3, e to the 2T cosine 3T, and then 4T e to the 2T sine of 3T. Let's again check for resonance. So the right-hand side, because of the e to the 2T cosine 3T, it would correspond to lambda equals 2 plus minus 3i, which again, it doesn't coincide. And so there's no resonance. Okay, but the question is, what do you guess here? Well, first of all, this 2T plus 3 and 4T have degree 1, so definitely something of degree 1. And here, my best suggestion is just do it by analogy with scalar equations. Because usually you would guess AT plus B, e to the 2T, cosine 3T, and then plus CT plus D, e to the 2T, sine of 3T. But now we just have everything in terms of vectors. So here, xp of t, it's still at plus b, but vectors. So abt plus cd, e to the 2t, cosine of 3t, and then plus eft plus gh, e to the 2t, sine of 3t. So once again, I mean, I hope I can convince you how similar it is to scalar undetermined coefficients. It's exactly the same rules. The only difference is we have vectors instead of scalars. And next up, as you might have guessed it, resonance.